Hello, welcome back to another episode of Stats with Mats. Quick, simple video today. We're simply going to be doing a homework review of the chi-square formula that I assigned. So, getting into it, homework this week asked you whether or not you could find evidence of a significant relationship between the country that one was born in, and we had three of those, and their level of trust in national parliament, of which there were four possible choices that one could ask. So you were given the following information: Germany, France, UK, and total trust, moderate trust, little trust, and no trust. Total number of people that we sampled here was 104, and the values that you see here are obviously the intersection of country of origin, a country of residence, and their level of trust in their national parliament. So knowing that this week we were doing a chi-square formula, that right there is probably all you needed to know, that this was going to require you to do chi-square on the homework. But even if you didn't know that, what you see here is all you need to identify that. You will remember that a chi-square hypothesis test looks for a relationship between two categorical variables, and those categorical variables can be either nominal or ordinal. So let's look at what we have here. Country that somebody was born in: Germany, France, United Kingdom. That is clearly a nominal variable. There's no inherent mathematical meaning behind that. We are just measuring differences in type, not in amount. And then total trust, moderate trust, little trust, no trust. That can be rank ordered, but we can't mathematically treat it the way we would a continuous variable. So that's an ordinal level of measurement. Looking at these two variables and recognizing that I cannot calculate a mean in a valid way for any of them, that right there tells me I'm going to be doing a chi-square formula. And furthermore, when it comes to identifying my independent and dependent variables, let's just look at how the table is set up. I have Germany, France, and UK in my columns, and I have total trust, moderate, little, and no trust in my rows. In a chi-square formula, I will always put an independent variable in the column. So the hypothesis here is that the country that one resides in is the thing that's affecting trust in national parliament, not the other way around. Because I could create a crosstab, I could create a table that had trust levels in the columns and country in the rows. That would not be wrong by any stretch of organizing a table, but it would shift the hypothesis. So because I'm asked if European country of origin affects one's level of trust in national parliament, I know that the thing doing the affecting is the independent variable, and the thing being affected is the dependent variable. So if we move on to our steps here, step one, what do you know? Well, my independent variable, country of origin, and my dependent variable, trust in parliament. It is country that one lives in that is affecting their trust in parliament. And then N, which comes in handy when we have to calculate Cramer's V, 104. And that's it. That's all. I can't list means. I can't list specific values. I just have to list the IV and the DV for this relationship test here. Okay, so moving on to step two, I must write my hypotheses in the English language, not in the mathematical language anymore. So the null hypothesis, H0, will be that there is not a significant relationship between country of origin and trust in parliament. There's no effect. The one does not affect the other. The alternate hypothesis, H1, we will classify that as there is a significant relationship between the country that one lives in and trust in parliament. And that's it. That's all I have to write. There is not a relationship on the null. There is a relationship on the alternative side. Okay. So what were we asked for steps 3 and 4 here? Well, we were asked specifically 99% confidence. Because 99% confidence gives you a 1% chance of making a mistake, we are now going to set our alpha level at 0.01. And you will remember that our critical value relies upon calculating degrees of freedom here. Okay, so the formula here is rows minus 1, times columns minus 1. I have 4 rows, so that's 4 minus 1 equals 3, and I have 3 columns, 3 countries, France, UK, and Germany. And so that's 3 minus 1. 3 times 2 equals 6. If I look at my appendix for the critical values of chi, when I have an alpha level of 0.01 and a degrees of freedom of 6, that correlates that becomes a critical chi-square value of 16.812. We are operating with a no-tailed test here. Therefore, I must calculate a value of chi-square in the observed data that is larger or greater than 16.812. All right, let's go to the videotape. You were given a somewhat helpful, or I hope somewhat helpful table that allowed you to follow the steps, follow the order of operations necessary to calculate chi-square for each individual cell. And we had to do that for all 9 cells and then some. But first, in order to be able to calculate frequency expected, I needed to get the percentage in each total category. And those I have highlighted here in red. So 31 people out of 104 total in the sample, 31 of everybody has total trust in Parliament. And so that is 29.9%. How did I get that? Well, I divided 104, which was my total number of people in the sample, into this 31, which is the number of people in the total trust category. That gives me 29.9. Did the same thing for moderate trust. 22 divided by 104 is 0.211. 25 divided by 104 is 0.24. And 26 divided by 104 is 0.25. So starting with the total trust cells here across the 3 countries, I need to take this 0.299 and multiply it by the total number of Germans, the total number of French, and the total number of British. So 0.299, let's scroll down just a little bit, times 36 Germans is 10.764. That is what I would expect to see in this cell if there was no relationship. That would mean that the percentage of Germans with total trust in Parliament mirrored exactly the percentage of everybody with total trust in Parliament. So then I multiply 0.299 times 30. That's the number of French people. That gives me 8.97. And I multiply 0.299 times, looks like 38, I believe. Yeah, 38 Brits, and that gives me 11.362. Once I have frequency expected, it's just a matter of following the formula. So let's go back to this first cell of Germans in total trust. I subtracted my frequency expected of 10.764 from the frequency observed of 14. That gave me 3.236, which I then squared to get rid of negatives if they exist. They do not here, but they do for the next cell where you see the French total trust number. And so then I take this FO minus FE squared and divide it by the frequency expected of 10.764, and that gives me 0.973. That is the chi-square value for this one cell of Germans with total trust. I run through the rest of the table, right, the way that we had to work through this, and my chi-square values are as followed. 0.973, 0.433, 0.163, 0.335, 0.858, 1.978. So that's large. That means there's a big difference there between what was observed and what was expected. Moving down to little trust, going left to right, 0.311, 0.45, 0.002, almost identical. 0, that means it is identical, FO and FE, 0.83, and 0.658. I sum all 9 of those values here, since we have a 3 by 4, or 12, actually. 1, 2, 3, 4. Yeah, 12, I'm sorry. Did I say 9? Yeah, I sum all 12 of those values, and I get a chi-square of 6.991. I don't know why it says 7.056 there. I'm sorry. The bold one is what you need to look at. God, next week, no mistakes. That's my word. 6.991, which is less than that critical value of 16.812. So that's the question that we have to ask here. Is 6.991 greater than the critical value of 16.812? The answer is it is not. It's actually not even close. So with 99% confidence, we cannot reject the null hypothesis. We fail to reject the null hypothesis, and I conclude that one's country of origin does not influence their level of trust in national parliament. Whole lot of work for nothing there, but not really, because now we know there's no relationship, and no finding is still a finding. What happens next? Well, I hope everybody remembered to heed my instructions of calculating Cramer's V. You were asked to calculate the strength of the association regardless of whether or not you had a significant finding. So Cramer's V equals chi-square divided by n times degrees of freedom asterisk, where that df is r minus 1 or c minus 1, whichever is smaller. So I went with 2 here because that was the number of columns minus 1, which gives me 2, which is obviously smaller than 3, which would have been the value for the rows minus 1, 4 minus 1. So 6.991 divided by 104 times 2, which is 208. And that gives me a Cramer's V. Once I take the square root, I calculated this at 0.184. That was a weak, though close to moderate, and insignificant relationship. It was almost moderate, and that's because if we were doing this at 95% confidence, we would have still failed to reject the null hypothesis, but we would have been a lot closer to rejecting the null hypothesis. So it's an example of how even an insignificant relationship can sometimes show a somewhat moderate relationship. But you look at the data here, and it's hard to say that there's a really intense or strongly held relationship between these two variables. And that's kind of it for chi-square. I encourage you to reach out and ask me questions by email or on Skype if there are concerns about how to work with this formula. But I don't think it's very complicated. I think it's something that just requires practice and comfort with the steps. Now, next week, that will change. Next week, we're going to be doing a much more intimidating formula. But again, what I hope people are realizing is none of this is impossible if you just commit to putting in the wrench work and doing the work to get the right answer, following the order of operations. We can test any collection of variables. And I hope that's becoming clear to people. I'm happy with the work that you guys are doing in this class. I'm proud of my students in this class. Keep it up, and we are going to get through this very well. All right. Have a great weekend. Stay well, stay healthy, stay happy. And I miss you guys. I miss you guys. I hope that you guys are doing well. Take care of yourselves.